I'm Hannah. Thank you so much for having me. I lead capital deployment at Frontier. We are an advanced market commitment that represents a bunch of large buyers, Stripe, JP Morgan, Google, H&M, and the goal is to buy carbon removal in a way that get these technologies out of the lab and into the field for the first time. We've committed over $700 million, and we have about a portfolio of 60 companies. So excited to talk about carbon removal. So this image is very familiar to the folks who are in the room, but we wanted to ground today's conversation about carbon removal in what the world needs to stabilize global temperatures. And as we think about getting to net zero by mid-century, we really need to think about not only radically reducing the emissions we emit, but proactively removing those emissions at scale. And carbon removal, as shown in this chart here, is not just removals on managed land, things like planting trees, but really thinking about what are the technologies we can use to proactively draw down carbon dioxide from the atmosphere and store it permanently. And we are really at the earliest innings of this market. And so while these figures are slightly outdated, they're directionally correct. To date, we've only removed about 50,000 tons of carbon dioxide permanently. And yet, as we think about the scale this market is going to need to get to, we need to be doing billions of tons of removal every year in the next about 25 years. And so we are just at the starting line for carbon removal.
So that raises the question, how might one actually go about pulling billions of tons of CO2 out of the atmosphere every year? Dozens of approaches have been suggested. Let's get a little concrete about this for a second. There are a number of ways that one might do this, but they really cluster into a few different categories based on the sort of fundamental chemical reaction that you're trying to use to convert that CO2 into something else. So one place we see a lot of carbon stored on Earth is in biology and biomass, organic carbon. So when a tree photosynthesizes, it's literally sucking CO2 out of the atmosphere to make tree biomass. That's one thing that people talk about doing, just planting trees. Then, of course, there are other ways that you can grow crops, and maybe you might want to burn those for energy, and then the CO2 that's released from burning that, you can capture it and store it underground. That's called BECCS. This is a very acronym-heavy field. I apologize. Or, of course, you could just grow biomass and then move that biomass underground and store it as a slurry or bury it in some other fashion. That's often referred to as biomass injection, or BICRS would be the acronym. Then, of course, there's other forms than organic carbon that we find lots of carbon stored on Earth. There's also bicarbonate in the ocean and carbonate, and there's also inorganic carbon. So these sort of mineral-based methods, one of them would be sort of accelerating the natural process by which the Earth cools over hundreds of thousands of years, or by which the climate basically remains stable over billions of years. That's called enhanced weathering. Another option is to transport the calcium ions in those rocks into the ocean, where they basically interact with the CO2 that's in the ocean to convert it into bicarbonate, hiding it from the atmosphere and inducing an air to sea CO2 flux. That's often called ocean alkalinity enhancement. Then, of course, you can actually pull reactive rocks from underground and put them in heap leaches where they can interact with the air. That's called superficial mineralization. And then lastly, we have sort of the kind of more classical method of direct air capture, which through industrial processes strips CO2 from air and stores it underground. So all of these different methods have multiple sort of subcategories within them, but this is a sort of useful way to frame the sets. All of these different methods, we need to ask a bunch of different questions about them if we're going to figure out if we can do these things at large scale. A basic question that we need to ask is, does it actually work? So is it effective at removing CO2 from the atmosphere, and does it keep it away from the atmosphere for a long time? Does it scale? So what kind of resources that are finite that there might be some sort of competition for, does it require, and how much do we actually imagine we could scale this up? How expensive would it be to do that? How expensive is it to do a little bit of it right now or a lot of it in the future? And if we are removing CO2 from the atmosphere this way, how do we know how much CO2 we've actually removed? And do we know that CO2 wouldn't have otherwise left the atmosphere if we hadn't done that thing? Another really important question, especially in the absence of a kind of global carbon market today is, are there any other upsides or co-benefits to doing a particular method? This is really important if you want to convince people to actually do something. Because, for instance, if I want a farmer to try to put some sort of material on their land that's going to pull CO2 out of the atmosphere, they're going to want to know what's in it for them. And the other thing they're going to want to know is it safe? So this is another kind of essential question that we always ask: are the environmental impacts sufficiently low or negligible? We obviously don't want to be leaching very large amounts of toxic metals or something else into the environment that could have other kinds of unpleasant consequences. And in some cases, we may also need additional regulatory frameworks for some of these. And so we ask all of these questions of all these methods, and we end up with a table, or this is at least my mental model of it, that looks like this. So this is very much subjective. This is very much uncertain. Some of these things are well known, other things are very much not. But we get a bunch of different yeses, nos, maybes, mediums, whatever you want to think about it as. And the point here is that there is no silver bullet. So all these different methods, they have some downside, and often cases, multiple downsides. And at the same time, those downsides are different for each individual method. So you see no green rows and no green columns in this matrix. And we're trying to figure these things out. But what this does tell us is that if we want to do this at a very large scale, there are big trade-offs involved, and we're going to need a portfolio of options. And it's really not clear just yet what that portfolio looks like.
So one thing that's exciting about carbon removal is that for the first time, we're starting to see meaningful deployment and delivery of tons of removal. And that matters because, as Cael was mentioning, there's a lot of uncertainties and trade-offs related to the different approaches that we could take to do carbon removal. And it's not until we see these technologies deployed in the field that we can actually start to learn what these real trade-offs look like and make decisions about where we should be concentrating capital and sort of doubling down our resources in the short amount of time we have to scale this market. So the Frontier portfolio has 60 companies. It represents the lion's share of the carbon removal market today. And so we can use the portfolio, the progress in the portfolio, as an indicator of how the market is doing. In 2025, we had about 20,000 tons delivered from companies in our portfolio. This is amazingly 2 times the size of the deliveries we saw in 2024. So we're really seeing that up and to the right trajectory that we want to see. And yet, 20,000 tons is so tiny compared to the billions of tons of removal we know we're going to need to do. So this is just the first inkling that we might be starting to see what this technology really looks like in the field. And even more interesting here is that we're starting to see deliveries across multiple major pathways. So as we're thinking about the diversity of technology, or this sort of portfolio that we want to be scaling to get to gigaton scale, seeing lots of different approaches tried in the field as soon as possible is important. So in the biomass, or the bikers column, we see there are a bunch of technologies specifically in the biomass and bio-oil injection fields that are starting to deliver credits. Within marine carbon removal, we have a lot of different companies that are taking alkaline materials and applying these to different bodies of water. So within wastewater treatment plants, to rivers, to coastal outfalls in the ocean. And for the very first time, we saw registered credits in this technology pathway in the last year. So we're really starting to see a commercial inflection as we look to ocean carbon removal. And then lastly, we're seeing credits generated in enhanced rock weathering. So this is taking waste fines from quarries or other crushed rock materials and spreading these on crop fields. And again, we're starting to see the first independently verified credits from enhanced rock weathering. And so sort of across a wide variety of approaches, we're actually starting to see things done in the real world and generate real credits. And maybe even more important or inspiring than delivery, we think a lot about capacity. Capacity is what's the size of infrastructure that is being built that will ultimately deliver carbon removal annually in the future. And again, we can look to the Frontier portfolio here. In 2025, for the first time, we saw over 1 million tons of new capacity break ground. So that's a new infrastructure that will deliver 1 million tons of carbon removal in the future once commissioned. This is, again, 2x what we saw commissioned or broke ground in 2024. And this is really an indicator of the delivery to come. And 1 million tons starts to sound slightly more industrial or commercial scale. So very quickly, we're moving from no deliveries to tens of thousands of deliveries to millions of tons of deliveries in quite a short span of time. And again, to give you a sense of what this looks like, there's kind of two flavors. You can think of what carbon removal infrastructure looks like in the real world. There's traditional large infrastructure projects, concrete and steel in the ground. These are facilities that will deliver hundreds of thousands of tons a year, likely. On the left-hand side here, this is a picture of Stockholm Exergy that is doing a carbon capture retrofit on their bioenergy facility in Stockholm. It will deliver 800,000 tons of carbon credits a year. And then on the right-hand side, you can see a totally different model. And these are more open system pathways where you may be doing more modular deployment or distribution. And in this case, we're looking at a quarry in the southeast of the U.S. This is a lithos project, and they're going to be delivering basalt rock to many fields that will deliver hundreds of thousands of tons over the coming years. So two models, but both that are delivering really scaled carbon removal infrastructure. So the progress on the technology side or on the supply side of the market has really been remarkable over the last couple of years in such a short period of time. And yet the question really remains for this industry, like, who's going to buy carbon removal or who will pay for carbon removal? Frontier can't last forever, sadly. When we think about the size of this problem in the future, we're looking at gigatons of carbon removal needed annually at $100 a ton. That's hundreds of billions of dollars of annual procurement spend alone. And so the question for us to grapple with is who's buying carbon removal down the cost curve and at scale?
So we've seen there's lots of different ways one could do this, and we've seen that a lot of those ways are starting to be implemented in reality, which is great. At the same time, I think it's important to recognize this is a gloomy moment or hard moment for carbon dioxide removal. So pesky academics like myself keep pointing out issues with various methods. Microsoft has changed its purchasing policies with ripples through the market, and I probably don't really have to get into the politics of the United States in 2026. That sounds like a bad thing, but there are, in a lot of ways, important or even essential sort of silver lining aspects to this kind of cockroach moment. So in a lot of ways, it's important to trim the fat, right? We are not actually going to see dozens of CDR methods in our imagined future gigaton portfolio. That's just not how these markets work. That's not how energy worked. It's not how CDR is going to work. So there needs to be some pressure to try to figure out what out of these many, many methods, various degrees of wackiness might actually make sense to do in practice. And that's exactly what a hard moment like this can provide. The other thing to point out is this is a very common sort of cycle we've seen many, many times for new technologies. And so this is something I think in a lot of ways we expect. So in many ways, it's important to recognize it's a hard moment, but it's not necessarily entirely a bad thing.
So as we're in this hard moment, we wanted to take a second to step back and think about what does the future of carbon removal look like as we sort of come out of the trough of disillusionment along the slope of enlightenment, if you will. And at scale, at gigaton scale, carbon removal is really a public good, one that is going to have to be supported by governments around the world. And yet there is an opportunity for corporate buyers to play today in helping to get this technology to what we call policy ready, which is really deployed at scale such that the technology is de-risked and deployed at such a scale that it's cheap enough that regulators can use it in a variety of different ways. And so we are really thinking about how do we grow this small-scale market from ambitious corporates to maybe expanding the voluntary carbon market, but ultimately to preparing the world for a policy-driven demand future. And so in this moment that Cael sort of rightly called a cockroach moment for carbon removal, we're really thinking about building in the long term in two ways. The first is that on the demand side, policy takes a really long time to materialize. You have to build coalitions and champions in countries. Those individuals need to write good policy. That policy needs to be passed. Once that policy is passed, it has to become operational and start paying out those dollars to good projects. And so we're playing the long game here on the demand side of carbon removal and really thinking about how do we start to do that work all around the world. And there are plenty of jurisdictions, importantly outside of the US included, that are interested in building a carbon removal program.
At the same time, there's important developments happening on the supply side. So first off, it's absolutely essential that places like Frontier continue to try to build or push forward sort of pilot studies so that we can learn how these things might actually look in reality. It's also important to keep trying to come up with new methods that might actually be that silver bullet or something a little bit closer to it. There are all kinds of new technologies that are being proposed all the time that seek to solve some of the fundamental issues with some of the sort of older school CDR methods that are out there. And this is an important piece of work to continue to do as well. And then finally, there are important roles for research in terms of trying to answer some of the key scientific uncertainties or questions that can guide deployment, can guide engineering design, and can guide sort of portfolio development to ask to what extent we should be or could be doing these things and how it might look in reality. There's a lot of research gaps left to close there too. So with that, I think we will close, and thank you again for coming to Chicago.